Hello and welcome to session 333 in the AISafety.com reading group. Tonight we will discuss the article A Definition of AGI by Dan Hendrycks and many others. Although the term AGI wasn't coined until 1997, all the way back to the Dartmouth conference in 1956, the researchers have clearly envisioned and sought some kind of core of intelligence. And quite a while ago in this reading group, we covered Shane Legg's definition of intelligence, which was achieving goals in a wide range of environments. This was very influential, but AGI as a concept never really had a commonly agreed upon definition. And for that reason, it became an increasingly confused term. It eventually mostly turned into a marketing terms by some of the companies that are pursuing AGI. For this reason, and probably also others, the AI safety community doesn't really talk much about AGI and is certainly moving away from it. There's a preference towards some terms like superintelligence that has a very definite definition, this one from Bostrom's 2014 book. And that's of course a sorry state of affairs, and that's what this paper attempts to correct, because as the paper notes, without a definition we won't know how far until AGI, and that is, if you'll pardon me, true by definition. I still think that clarifying definitions is exceedingly valuable for this task of orienting ourselves and finding timelines as such. But still, a definition needs to refer to something real or something that cut reality at the joints to really be worthwhile to have. And thus the current paper, A Definition of AGI, which at a very high level contains the following short definition. AGI is an AI that can match or exceed the cognitive versatility and proficiency of a well-educated adult. So to this, I will give what I consider the obvious question, like what would be the consequences of us achieving AGI by this definition? There isn't really any hint of any answer in this article. I actually suppose that if I asked the authors, I would get puzzled looks as reply. And it feels to me like AGI by this definition would be able to do most jobs that are currently done by well-educated adults. Would that be a consequence? No. The authors reject any such speculation, and they argue against using their definition for predictions. Rather, the reason why they like their arguments, their definition, is because this is a definition that is amenable to systematic investigation. I fear this suffers from what is called the streetlight effect, because if we truly are interested in something else, then the fact that this definition is easy to operationalize is insufficient for us to really care about it. One thing I would say about this definition is that it's exceedingly legible, and for this reason I expect that it would retrieve like non-trivial media attention as we get near like AGI by this definition. Since this definition of AGI is based on human proficiencies, then psychometrics, or what is known as like personality tests, become central. The authors base how they operationalize their definition on a standard theory called CHC. This, they claim, is the most empirically validated model of human intelligence. This criteria here shows that they're really going all in on a human-like intelligence rather than general intelligence. And this tension between human-level intelligence and general intelligence is a theme we will return to. CHC theory provides a hierarchical taxonomic map of all of human cognition. And that is useful because one of the things the authors see as absolutely critical is to exclude places where the AI cheats by compensating for deficits. But for actual capabilities, it might be very important if an AI unexpectedly gain new capabilities by compensation in some way. So for a security point of view, safety point of view, that's very important. But Dan Hendrycks is unmoved by this, because if there is a single cognitive thing that humans can do that the AI can't do, then it's not an AGI. No exceptions are allowed in his definition and worldview. And to me, this feels like a mathematics teacher that insists that a child should do the work according to the teacher's instructions, even if the child has a different way. Since many personality tests already exist, we do have a solid body of work to both isolate and quantify the proficiency of humans and also models. And a number of these tests are selected by the authors, and with this we can test them all and directly calculate what they call an AGI score. And if an AI passes all the tests, well, then it's an AGI. And so the definition and the division into cognitive area, that follows CHC, but the actual tests do not. And I would have appreciated some more thoughts on the test design before they just launch into presenting it. The 10 areas of CHC theory I'll show them in a moment, and each of them grants 10% of the AGI score. First is general knowledge, like breadth of factual understanding of the world, reading and writing ability, mathematical ability, on-the-spot reasoning, which is the flexible control of attention to solve novel problems, working memory, which is the ability to maintain and manipulate information in active attention, and long-term memory storage, which is about continually learning new information, and long-term memory retrieval, that's the fluency and precision of accessing stored knowledge. Visual processing, the ability to perceive, analyze, reason about, generate and scan visual information. Auditory processing, discriminating, recognizing and working creatively with auditory stimuli. And speed, the ability to perform simple cognitive tasks quickly. Okay, let's first begin by looking at general knowledge. What kind of general knowledge would a well-educated adult be expected to have? The tests pretty clearly show that GPT-5 is close to fully proficient here. I looked at the questions, and there were in fact a lot that I could not answer. I've reproduced some of the questions here, and like maybe I'm not well educated, or I suppose I could just be dumb, but those are really hard questions, right? The AI is in fact allowed to get a small number of the questions wrong in this, so they don't have to answer all of them. But like here are some questions that I thought were tough for me, but they are from a set that is called illustrative, and as far as I can tell, even the ones I could solve, I could barely solve them. Like this is a really hard test. Then there's test for reading and writing, and this is basically solved. GPT-5 reads and writes at a human level, period, right? So for the purpose of this AGI test, further progress is irrelevant. But of course, for the purpose of reality, progress matters a lot, right? It matters a lot whether GPT-6 becomes better at reading and writing for many, many practical purposes. Then there's mathematical ability. It's basically solved, right? I have a bachelor degree in mathematics from 20 years ago, and it is very, very clear that I've been totally surpassed in mathematical ability. We are far above the level of a well-educated adult. As for solving new problems, GPT-4 was measured to have 0%, whereas GPT-5 has like 7 out of 10 compared to a well-educated adult. And that was actually surprising to me. So I tried to reproduce GPT-4's performance. So I gave it some of the tasks, and there were in fact a number of them that it succeeded on. So I could not reproduce the results in this article. Dan remarks that solving new problems is something that in humans is strongly correlated with IQ. But the thing we are measuring is not IQ, right? And so for this reason, Dan only thinks that only assigns 10% weight to the metric on the spot reasoning, whereas for a more normal conception of intelligence, like IQ would in fact be a very large part. And of course, we know very well how to test IQ, right? Because we have things like completing sequences in Raven matrices. Here's an example of one of them. The authors don't exactly state what's the benchmarks, but it's easy to calculate that they are testing towards a benchmark that is like 20 IQ points above the mean. I do also want to point out that a lot of these tests are pretty strongly confounded by visual ability. Like the tests are images that are of really poor visual quality. One test in particular that GPT-5 failed to solve is the Wisconsin card sorting test, which is a surprisingly simple test. It's actually often used as a test for cognitive impairment. And I would like here to register a prediction that this result will totally fail to replicate, or there is some silly technical problem that will prevent GPT-5 from solving that test. Working memory is a place where GPTs are struggling, though they are improving. Here's an interesting example of a test that they fail. So we are comparing elements to see, visual elements to see if they are identical, and I try to reproduce this, and sure enough, GPT 5.1 fails this test fair and square. It gives an incorrect answer, and I tried to ask why, and then it described how it solved it, and it was really clear that the reason why it failed this was 100% due to a failure of visual processing. And then once it had identified the features of the different aircraft in this case, then it was very easily able to like manipulate like the descriptions in working memory. That wasn't actually the problem. And I think already I'm really at this point seeing a pattern in that there are some limitations in these tests, and all of them are in modalities that are not text. So that is in fact the thing that we are measuring. If there is something that is structured in a way with input and output in the way that we normally use GPTs, then they are by default passing all these tests. Now GPTs fail utterly in long-term memory storage. That's what Dan Hendrycks called it. I think I would rather call it medium-term storage, because the tests are described in the main body text as referencing content from yesterday or today. And like, depending, like, I often have a prompt open in ChatGPT for more than a day. So if you just continue to write on the same prompt, then obviously that works perfectly. So the question here is, how do they in fact define yesterday? And they do that by first presenting the LLM with some extremely simple basic facts like, I don't know, Alice is 43 years old. And then they give the AI 48 hours worth of experience. And then finally they ask it to recall the simple fact, like how old is Alice? And it totally fails, right? So first, a silly complaint is that, they write explicitly yesterday and today, and 48 hours ago isn't actually yesterday or today. But the real complaint, of course, I have is like, what does it mean in practice to have 48 hours worth of experience? And throughout the text, there is absolutely no hint given what 48 hours worth of experience is. Like, there are many ways to implement this. Like, the most silly and easy way would just be to close the session. That is consistent with the result that absolutely nothing, no information gets across this 48-hour gap. But I think like a more fair comparison would need to somehow incorporate the context window. which is a parameter where there is a difference between GPT-4 and GPT-5, but I don't think this was done. Another test in this area that I felt was very unfair was that Dan Hendrycks uploads a copy of the Star Wars movie to ChatGPT and then asks questions about that. And the authors are explicit in defining the test such that if the upload fails for any reason, then it fails to be an AGI for this reason. And the problem here is that GPT-5 is very well aware of the script of the Star Wars movie, right? They really know that like Darth Vader is Luke's father and all these things, right? So the only reason why it would fail this test is probably because the upload failed, right? So the authors don't write that, but I expect that they tried to upload a movie and then GPT-5 interface said too large file, and then they say, ha, it couldn't do that. Long-term memory retrieval is an area where GPTs are scoring substantially higher. And here long-term retrieval are things that are learned during training. So it's not facts that are given during the test. So initially it was pretty puzzling to me why Dan Hendrycks insists on really hard time limits on this part of the test. Because for humans, like if you don't know the capital of Sudan, then like getting 1 more minute to think about that usually doesn't help very much, right? But when I looked into the appendix for how the actual tests were done, they turned out to be mostly be a matter of very, very quickly naming associations and lists of facts. I would, in fact, think that GPTs are pretty superhuman on this task. And the only way that humans can like mention more synonyms for something of faster is where there is a very high requirement for speed. That's the only way humans can really compete. And some of these tests are like literally only speed. Like imagine one of the tests is you show the ChatGPT a picture of an apple and then say, what does this depict? And if the AI is slower than a human, well, then it doesn't have long-term memory retrieval, which I think isn't really fair. I don't think it's fair to call it long-term memory retrieval because this kind of test is purely speed and visual recognition. Another test that I actually thought was way more interesting was one where we are testing whether the AIs share the human problem of taking longer to identify colors if the colors are inside like the font in the text for a word where this word spells out a different color. Humans take longer, and the AGI, the AIs that were tested took even longer, but I'm somewhat confused about whether that is in fact a real test. Like I don't really trust the authors that say it's a real fact, but I think it would actually be pretty interesting to learn if this is actually a real thing or just another artifact of their really problematic texts. Finally, there is a requirement for human level performance that is hallucinating at most 5% of the time. And so I'm somewhat a bit surprised that GPT-5 isn't an improvement on this metric, because to me it seems like hallucinations is dramatically becoming a smaller problem. But I think it's fair overall. Hallucinations is in fact a real problem. But there is a technical problem that I feel totally invalidates this part of the test. And that is, they are not just testing propensity to hallucinate. They're testing propensity to hallucinate on a dataset that is adversarially generated towards GPT-4. And I think this is a totally unfair way to do a test. And the fact that they don't write this, and I had to actually follow the references at the end to discover this, is, in my mind, seriously dishonest. Here is this an unusual image? That is a question that will help determine the visual processing ability of an AGI. Now, GPT-4 was really limited in this, so I think giving it a low grade is probably fair, and things are improving, right? Some of the tests are a bit odd. In particular, generating video. Like GPT-5 can generate video, but humans can't generate video in the same way humans can write text, right? In some obvious sense. But Dan Hendrycks defends the inclusion of this test by saying that humans using tools like cam recorders are in some sense doing the equivalent for how the AI generates video. And I think in one sense, this needs to be like really far from any kind of standard psychometric tests mentioned in CHC theory, right? With this requirement to generate video. I think a more fair operationalization of AGI would just omit this test, because like that's not a thing that well-educated humans do in any reasonable way.
Can I ask a question there, Soren?
Go. Yeah.
I actually don't understand the question and answer. In what way is this image unusual?
Yeah, that's an interesting question. I actually took that because I was, in fact, a bit in doubt. You might not have a general intelligence if you say that this is a usual image and not an unusual image. Like, I'm kind of pointing towards that this is a test that is like underspecified. There's a lot of degrees of freedom there. It's something where a lot of people can debate, is this in fact a fair test of visual processing or is it not?
I mean, I think GPT-5 is context aware enough to understand that in the context of a test like this, you know, people in costumes would be counted as unusual.
Yeah.
Oh, is that the answer? The fact that the people are unusually dressed?
Are they in fact unusually dressed? I don't know. You might have better eyes than me, and so say, is this like an unusual? Are they dressed?
I mean, asking things like
it looks like they're dressed in dinosaur costumes.
Possibly, yeah. And so, that's of course a thing, right? My eyesight is pretty bad, so it is certainly possible that other people with that are not myopic are able to see some things that I'm not able to see, and I am not I'm inclined to feel that that is pretty okay, in the sense that, yeah, I may not be like a general intelligent human without my glasses, right? But yeah, it is definitely something that I think most of these tests are open for interpretation. Yeah. Okay. Yeah. But I should also say that while some of them are open to interpretation, there are also some where I feel, yeah, a smart human would in fact be able to do this task. This is an example of a test that seems like tough but fair in a sense. Like when I looked at this image, I was in fact able to tell which is correct, and GPT-5 was not. So there are in fact challenges with visual processing. Then there's speaking and listening. That's also a task where GPTs are improving pretty rapidly. And a lot of these tests seem pretty subjective to me. There are also things that seem irrelevant, like keeping a rhythm. That's something humans can do. And some people will say that, yeah, music and keeping a rhythm and clapping and singing is a central part of what makes someone a human. And then there are people who would say this is pretty peripheral in a sense. And I think there's a lot of things to quibble with here, but I think the overall conclusion that AGI isn't quite there on audio is probably reasonably correct. Then finally we get to speed, an area where GPT-4 and 5 are not improving. And when I look at how these tests are implemented in the appendix, they are not really measuring velocity. They are measuring acceleration, because a lot of these tasks are very, very brief. And Dan notes that it's important when you are reproducing these results that artificial delays like lag over the internet needs to be included in the test. And I'm not entirely sure this is fair, right? Because sure, if we are measuring precisely how human-like the AI is, then you need to consider things like internet connection, right? But we are in fact if that was what we were measuring, we should not have called it AGI, because that's a different thing from human-like AI. And I'm also, when I look through this test, I consistently feel a need to see the actual results, right? How large is the difference? What were the reasons why they failed? I think that would be really, really handy to include. One thing you can do with these models is to change the thinking time. And Dan notes up front that it's against the spirit of this test to change the model from auto to instant, as the GPT-4 and 5 are called. And I think I would disagree, because for any possible use case where speed is really, really essential, then yeah, you would change in the drop-down menu, just change the model type. And I think this requirement really handicaps the AI here. So one of the examples is a test that's just to say hello as fast as possible after hearing the instructions. And yeah, GPTs can't do that in the default state, but there are some with a different technical setup, and they are totally able to reply very quickly. There was another test that I was very confused about. That was how long time after you read a 100,000 token prompt does it take for you to begin answering it? And that was a really strange test, because there must be something I'm misunderstanding about the details of this test, because reading 100,000 tokens and starting to reply on them is something that GPTs ought to be extremely, extremely superhuman at. There's absolutely no way that would take me, I guess, hours. So how does GPT-4 and GPT-5 fare in total across all these? Well, here's the results. And if you sum it up, it's 27% for GPT-4 and 57% for GPT-5. The authors summarize this as substantial progress, but a substantial way to go. And if we extrapolate directly, then we have seen 30% progress in 29 months. And if you then do some very simple math, you can conclude that we're on track to having 100% AGI in February of 2029. AGI in February 2029 is something that is reasonable. It's actually roughly the same as I would put on AGI for my definition of AGI. I will return later to my definition of AGI. But the thing that strikes me here is how this test wasn't pre-registered in any way. And there's just a huge number of degrees of freedom in this. So I suspect that if there was a pre-registered test, then it would struggle a priori to set a challenge level that would result in something in between 0 and 100%, really. Maybe that's a bit pushing it. But the authors don't really want to speculate on how long time it would take us to reach AGI. The only thing they're willing to say is to say that 100% AGI is probably something that won't happen in the next 10 months, which I still remember the heady days in 2020 where that was before we moved all these goalposts, right? Back then, long timelines referred to AGI before 2075. So yeah, 10 months, I don't know if that's long or short now. Okay, so throughout this, the primary limitation that's found by these tests are problems of long-term memory, especially learning and visual recognition. And overall, I think that's a correct and central conclusion. And So in that sense, I appreciate it. I also must caveat that I don't think it's a very original conclusion. Many other people have noticed this. And of course, the fact that many people know that this is a problem means that some of the best researchers in the world are working very hard to either overcome these obstacles directly or find some way to get around them. Personally, I would suspect that long-term memory, as distinct from learning new facts, is the most likely of this to be straight up solved. Dan Hendrycks predicts that this will require longer context windows and that will be unable to scale up to the human level. I suppose it's possible that we won't get longer context windows, but I would like to see a bet to know what are the author's actual confidence levels. For learning basic fact, Dan claims that we need a persistent, updatable store for private interactions. And we kind of have that, right? We have retrieval augmented generation, RAG. That's basically it, right? But in Dan's view, this doesn't really substitute for any kind of holistic, genuine learning, which is required for AGI. There are other limitations with Joint GPTs. They don't really get a heading. If I should put a word on it, I would call them synergistic limitations that prevent GPT-5 from being an AGI. For instance, if we take the composite social intelligence, that requires potentially a large number of subtasks. But I'm not entirely sure they do, or at least it can't be a hard requirement, because we have literally seen people fall in love with 4.0, right? So the statement that has 0 social intelligence can't actually literally be true. When Dan describes these cognitive components, he uses an analogy with an engine, where if an engine has, like, its durability is limited by the worst component. And I'm not entirely sure I would agree that such a tight requirement exists, because, like, in the most extreme case, like, there's a task of keeping a rhythm, right? And if that fails, well, so what, right? There's a lot of other things the AI can absolutely do, right? Many of these small individual cognitive abilities don't actually prevent that many things from happening. So this idea that it's an integrated machine feeds into a general view of intelligence as a highly integrated set of skills and proficiency, and that has actually some worrying implications, because if we believe that it's highly integrated, then once the final piece of the puzzle is placed, well, then suddenly it goes from being able to do very little to doing a lot. So we could see performance skyrocketing at some future point. My overall conclusion on this is that it feels like these tests are, give me a moment, and I'll cut this out in post, I think. Okay, so in conclusion, it feels to me like these tests, in a somewhat surreptitious fashion, relies a lot on factors that are not commonly associated with artificial general intelligence. I predict that a more fair operationalization of the same definition could in fact result in a far higher AGI score. Okay, I've been highly critical of Dan Hendrycks' definition as well as his operationalization. So, can I do better? Yes, I think I can. So here is my definition of AGI, artificial general intelligence. And again, we'll start at a high level, where in a very abbreviated form, AGI is a statement. And AGI is an AI capable of takeover. Okay, first things first. You will notice that the Hendrycks definition emphasizes the generality of the AI with a large focus on the breadth and the modalities. Where my definition, sure, that requires a substantial breadth, but there's a much higher emphasis on cognitive performance. It's possible to argue that my definition differs from the historical definitions. I think it's closer to the historical, but I'm not too bothered about the history of the term. I think instead, one clear advantage of my definition is that the consequences of CERN AGI are very serious and very decision relevant. Okay, but Dan Hendrycks could operationalize his decision really well. Can I do the same? Can I find some way to test how far we are towards AGI? I believe I can to some extent. So here our objective is to define a set of tests that determines in advance if an AI is capable of performing a takeover. So first, a small digression, because some AIs might be able to take over, but they also might not. They may have a probability of taking over less than 1. Are they an AGI by my definition? And I would mostly choose to disregard this question, because I expect that there's only a very small cognitive difference between an AI that has a 5% probability of takeover and one with 95% probability of takeover. Instead, let's look at the cognitive skills and divide them into 6 categories. This is, of course, following Nick Bostrom's 2014 book. Within each of these 4 domains of cognitive performance, I think it's pretty feasible to generate tasks that measure human performance. And if we can generate tasks, well, just like in chess, we can calculate an ELO rating for any human. And if we measure a lot of humans on their skill at hacking, then in theory we could find a maximum human ELO score for each domain. Of course, in practice, like tracking down the best hacker might not be trivial by definition, so there will be some guesswork, but we can estimate it pretty well. And then we can give the AI the same tasks. Critically, here we allow all affordances. And if we do that, in theory, we could calculate their ELO on all these 6 dimensions corresponding to the 6 cognitive domains. And once we have that, well, we can see that once the AI is above the human maximum on all the areas, then by definition, this is a weak superintelligence. My intuition is that once we see cognitive performance that are 2 standard deviations above the human level, that would be the level that is roughly required for a takeover. And that allows us to, for any AI, calculate an AGI score according to how far it is from being able to make a takeover. Quite a ret demonstratum. So obviously I recognize this isn't perfect. There's still quite a few degrees of freedom. I am confident that this is a dramatically better and more consequential definition than the one that the authors present in this paper. That concludes my presentation of A Definition of AGI by Dan Hendrycks and many others. Ceterum censeo, machinam sapientam esse delendam.